Hi everyone. Right now we will talk about the transformer and its experiments. We need to talk about DC test, open circuit test, short circuit test, and load test. For DC test, we would like to calculate the primary and the secondary resistors. For open circuit test and short circuit test, we will calculate X1, X2, R4, and XM. And then we will apply load to see the efficiency of the transformer. Let us start by talking about the DC test. But please pay your attention for the DC test because of the transformer full load power. It is 1000 volt ampere and the primary voltage is 240. So if we're talking about DC, we are applying DC. Please pay your attention that the current will be very small because you don't have X, you have only resistance. So I'm expecting that the current will be high because the current based on that winding will be equal to V divided by Z. In our case, for DC, we don't have Z, we have only R, which is R1. That's why I will be careful while I'm applying voltage here, which is DC volt, and I will measure the current and the corresponding voltage and divide them to find V1. Like what we did here. For DC, let me show you the transformer. Okay, I'll draw it. So for this circuit, we are going to apply DC source, VDC, and we will measure IDC, and then R1 is equal to VDC over IDC. We will repeat the same story for the secondary one. So what am I going to do? I'm going to connect this guy to DC source and this guy. But pay your attention, we are going to use variable DC, not fixed one, because I would like to use very, very small supply voltage. At the same time, I would like to measure the current and the voltage, so I will connect this guy to this guy, which is the emitter, so the current is going from this guy to the emitter, going back to my supply, my transformer. Then I would like to measure the voltage as well, so I will connect this guy and this guy to E1 to measure the voltage. So those are measuring the input voltage. Then I will use the data acquisition system for doing that purpose. So I will adjust this guy to measure DC for E1 and I1 to measure DC as well. I don't need this, I don't need this, I don't need this, and I don't need this as well. And this guy is measuring the resistance as well. So I will turn on and then start taking a reading for the input voltage. Like for example, let me take the input voltage, whatever its value, it doesn't matter, any input value. So let us take, for example, as you are seeing the resistance here, this is the resistance. So let us make E1, for example, 1.896, and the corresponding current here, which is I 2.6. If you divided those, it will give you the value of the input resistance. I'm going to repeat the same story for the secondary winding. I will not do anything except moving these two to this winding, for example. And measure the resistance for this winding. Do the same and see the input voltage, any voltage I'm going to apply, and measure, see the current. Although the voltage is very small, the current is high. So pay your attention. I don't like the current to be increased. So probably I will keep 1.3 1 point, okay, I'll keep this value, which is almost 1.34, and the current is 2.6, and this is the resistance as you are seeing. So I'll keep one value, and then I will start talking about the next part, which is the open circuit test. So for the open circuit test, what I need, let us see the open circuit test circuit. So this is the open circuit test, and this will be the equivalent. So what we need to connect the supply to here. He connected the supply to these two windings. And like what I mentioned during the class time, where should I put my measurements? I put them here in the secondary winding that has low voltage. So for open circuit test, I open this guy, which is, in our case, we are considering it at the primary, and we connected this point to this point, and this point to this point. So the start to the start and the end to the end, and then the supply, I'm going to connect it. So the first step is I will connect these two windings because I'm going to feed the voltage here. So I'm going to connect this guy, like what he did, to this guy, and this guy to this guy. This is what he did here, as you are seeing. So he connected this end by this end, and this start by this start. Then the supply will be between this point and this point. So my supply will be through one of these two. So it will be between this and between, for example, this one. Don't connect this guy here because these two are the same point and these two are the same point. So I can use either this or this for this part. And for this, I can use either this point or this point because they are the same. So this will be my supply. I'm going to connect my supply, pay your attention. This is AC, it is not DC. So I'm going to connect the supply across this guy. And what I need to connect ammeter and voltmeter. So what am I going to do for the ammeter? In order here. So I'm going to connect my ammeter here. So this will be the same point, and my ammeter will be connected between these 2 points. This is my ammeter. So the current is going from this guy to this guy, going back to the circuit. And this is the second part. Then I would like to connect voltmeter, and the voltmeter could be connected between these 2 points or these 2 points. So I can connect my voltmeter between this and this, or between this and this. It doesn't matter, because it will give the same. So I will connect my voltmeter here. This will be my voltmeter. And I will apply the voltage and see what's going on. So I will turn on, but before I start doing that, what I need, I would like to measure E1 as an AC and I1 as an AC, and I would like to measure the power P as well. So this is the power P, and I would like to measure the output, so I need to connect for the output. If you would like to measure it, you need to connect voltmeter, but actually I don't need anything for the output. I don't need this part. I need only Vn, In, and power in. So I will turn on, and then I will start changing my input voltage. I'll take different measurements, not only one, because he asked me to do that. For example, I'll take this is first one, which is Vn 30.15,
and I1 is 0.135, and the power input is 2.87. I will change the voltage. Let us take another reading. For example, I will take any reading. I'm taking some measurements. Let us take, for example, 60.45 voltage and the current, which is 0.203, and power 8.85. Let us take another reading, like for example 90, for example. Let me increase to see different values. So for example, I can say the voltage is 90.8 and the current is 0.36 and the power is 18.5. Let us take another reading. For example, let us reach to the maximum one that I have here for the power supply, which is 120, and the current is 0.84 and the power is 31.97. And I will repeat the same story for the short circuit, like what you are seeing for the short circuit. What he did, he short-circuited these two windings and he supplied this. So what am I going to do? I'll do the same. I will turn this around. I will feed from this guy. So what am I going to do? This guy is my power supply. I will not change anything because I'm repeating the same story. This is my power supply. So this is the power supply voltage. And I would like to show those, like what he did. He connected this point, like what you are seeing, he connected this point to this point, and this point to this point, and then shorted them. So this is what I'm going to do. This point is connected to this point is connected to this. Then I will short these two. I can put the short circuit between this point and this point, or between this point and this point. It doesn't matter. But pay your attention again, because I don't like the current to be increased in case of the voltage circuit, because the power is equal to 1000, which is S volt ampere. And I'm expecting voltage here maximum, which is 240. So if you divided 1000 to 240, it will give you around 4 point something for the rated or the full load current. So I'll pay my attention. The current here in the supply will not be more than 4, because the maximum current is 1000 divided by 240. It is 4 point something. I will keep only 4. Then I will start from the beginning again. So I will turn this guy on and I will start, but I have to be careful while I'm changing the voltage, because as you are seeing, the current is high. I just started. So let us assume that the voltage is 1.04 and the current is 0.4 and the power is 0.413. Let me increase the voltage a little bit, make it, for example, 2. The voltage is 2.07 and the current is 0.9 and the power is equal to 1.9. Let me change more. Voltage 3.8 and the current is 1.9 and the power is 7.3. Let me increase more. The voltage right now is 5.7 and the current is 3.25 and the power is 17.67 or around. Let me increase more, but I will not reach to more than 4. So let us take this reading, which will be our last reading. that will be, for example, 8.6 for the voltage, the current 3.8, and the power is 29.8. Then I will go to the last part, which is talking about the load test. For the load test, I'm going to do the same, but instead of short circuiting this part, I'm going to connect load and I will measure the voltage and the currents. So what I have here, this guy is short circuited, so I will disconnect the short circuit, and then I will connect this guy to load. So I will connect load between this point and between this point. This is the load that we are going to use because I asked you to use, for example, 240, 120, 60, 30. I asked you to use different loads. And here, what we have all of those are connected in parallel if all of them are on. But if one is on and one is off, so I will, for example, all of those three are on, so all of those three are in parallel, and those are in parallel. So I will play with that load. I will start, for example, by using 240, then I'm going to use 120 only, then 60 only, then 30 only, then I'm going to use some parallel combinations. So this is my load. Let me use longer wire. So this guy will be my load, and I will connect my load between this point and this point. What else I need? I would like to connect a meter and voltmeter for measuring the power, for measuring the voltage, for measuring the currents that will be through the load. So I need to have a meter. I will connect it. So for the meter, I'm going to disconnect this guy and connect this guy here, and then my meter will be between these 2 points. So my meter will be between this one and this one. And then I need a voltmeter connected between these 2 points. So, or a voltmeter connected between these points, they are the same. So I can say I will connect voltmeter between this point and this point. So these two are representing the voltmeter E2. My circuit is ready right now. I will start by 240, for example, and then I will use AC, and I will use E2. I will use as well I2 and this power. So this is the power input, this is the power output, this is V input, this is V output, this is I input, this is I output. I will turn on my circuit and I will reach to a specific voltage value, but actually I would like to reach to as much as I can, 200 volt, to reach to the full load voltage. For reaching to that voltage, what I need to do is I need, instead of using this guy and this guy as line to neutral, I'm going to use 2 different phases. Because the voltage between these 2 phases is 200, almost 208. But if I'm connecting these 2, the voltage is almost 120. I need to reach to the full load of this, which is 240, approximately 208 is okay. And then I will start my circuits, then I will turn on, and don't bother yourself for the sign because of the connection, that's okay. I will try to reach to 200. For the input voltage. And I'm keeping my eye on the current as well while I'm increasing the voltage value. So I reach it to the maximum value that I have here. The input voltage is 206 and the output voltage is 103 and the input current is 0.399 and the output current is equal to 0.435, and this is the input power, and this is the output power, which is 44.9. This is in case of I'm connecting 240. What am I going to do here? I will disconnect this guy and connect this guy. So I will turn this off and then connect to 120 and then turn it on again. These are the readings again that I got for the input voltage, input current, and the same for the input and the output power. I'll do the same, but I will again turn this off, connect 60 only, and then turn it on and see the voltage here. Do the same. I will change this guy and I will connect 30, for example, and I'll see. This is in case of 30 ohms only. I'll repeat the same story again, and I will connect two different parallel, like for example 120 in parallel with 60. So this guy is on, this guy is on, and at that time I will turn on again and see the input power, the output power, the input current, the output current. There is a slight difference between the values, which is okay, it is acceptable, but like what you are seeing, these are the values. I'll repeat the same story again, and I will connect in parallel again 120 and 60 more. So I will turn this off, so I will connect one more 60 and 120. So I have 120, 60, and then turn it on and see the readings. These are different values that I got for different loads based on different operating conditions. So this is the end for today's lab. I have already covered DC test, open circuit test, short circuit test, and load test. I'll see you for the next lab. Bye.